Welcome to Quadratics Lesson 7. This is the final lesson for this topic. It will really be a lesson that just summarises the most important parts of the topic, focusing on really the most common SQA exam paper questions that are coming up. Okay, so first thing, let's remind ourselves what the y equals x squared graph looks like. Y equals x squared looks like, oh, not too bad, oh yeah. Okay, the turning point at the bottom is 0, 0. That's the minimum turning point, okay? That graph there going through 0, 0. I know it's not perfect, but that graph there is the graph of y equals x squared. We're just talking about the sketch of it. It looks like that, okay? That's the general shape of it. I'll also do the shape of the y equals negative x squared, okay? That's this one here. I suppose you could say it's the upside down version of it. We call that a maximum turning point, and it has a maximum turning point also of 0, 0, okay? The x squared one is the black one, okay? Right, okay, down here we've got a typical SQA exam type question. This is one from 2014, and this is following the sequence of the lessons, okay? So we've done this in lesson 1. So this type of question, we've got y equals ax squared, and we've been given a point on it. The point on it is negative 345. Now, this negative 345 coordinate, that's your x value, that's your y value. All we simply do is sub that into our given equation. That's the equation that we've got. So we're going to put in x is negative 3 and we're going to put in y is 45. So y is 45 equals, don't know what a is a. Remember ax squared means a times x squared, so I'm going to write a times negative 3 squared. Okay, 45 therefore is equal to a times by negative 3 times negative 3, non-calculator, 2 negatives multiplied to positive, so it's a times 9. Really what you've got there is a times 9 is 45. Well, what's a then? If a times 9 is 45, a is 45 divided by 9. How many 9s in 45? A is 5. 5 9s are 45. So a is the number 5. Okay? Right, okay, next one. Most of these questions, you'll notice we haven't really used the calculator much, okay? We haven't used it at all just now. These do tend to come up in paper 1, but very soon we will get to a calculator question. Right, okay, these type of graphs, okay, minimum turning point is shown in the diagram is 2, negative 4. These are the graphs that look like that in terms of the equation, okay? The a value is something to do with the x coordinate. The b value is something to do with the y coordinate, okay? Now, it says x plus a in bracket, find the value of a. So it says that y is equal to x plus a in a bracket squared plus b, okay? Remember when we were doing this, what that means is, for our equation, it's not x plus 2. I know this is positive 2 here. Right? This is the number positive 2 on that number line, but it's actually x minus 2 in the bracket, we're right. Okay, I think we've done this in lesson 2 or 3. And at the end, plus b, again, it says plus, not necessarily a positive number. It's how much you go down. Okay, there you are, down 4. Okay, if this was a positive 4 on the y-axis, if this was a turning point that went to positive 4, up 4 on the y-axis, your turning point would be plus 4 at the end. Now just be careful. The question actually said find the value of a and b. Well, a is actually negative 2 then. Okay, please make sure you answer the question, okay? And it said what's the value of b? Well, b is negative 4. So that is our actual values. That is a negative 4. Doesn't look like it. Let's see if I can make it more like a negative 4. That's a bit better. Part B, write down the equation of the axis of symmetry. The axis of symmetry always is directly through the turning point. The x value of the turning point, the x value of that turning point is 2. Okay, it comes from the coordinate point, x is 2. You can actually read it from here as well. Positive 2, x equals positive 2. Okay. Right, okay, next one, quite similar to the last one, okay? Same type of graph, same type of equation. We're looking for these equations here. The axis of symmetry is x equals -5. What's the value of a? Right, well, remember we've actually just talked about the line of symmetry always goes through the turning point. That's a y equals, right? The axis of symmetry always goes through the turning point. So that means that that number on the x-axis there is actually -5, okay? But remember, when we're talking about this number up here, it means that a is actually +5. Okay, I don't know why I put that there. The question is find the value of a. A is +5. Okay, so this equation actually looks like x plus 5. That's what the equation looks like. We don't know b yet. Okay, that's why I'm just going to write plus b. That's what our equation looks like. If the turning point is a -5 on the x-axis, we write x plus 5. Remember, it's the opposite sign. So a is 5. Okay, we've already answered part A. A is 5. Part B. The point -3,8 lies on the parabola. What's the value of b? This ties into the very first slide that we had up there at the very beginning. If you've been given a point, sub it in. Okay, we know a point, sub it in. What we subbing in? Well, -3,8 actually means -3 is our x value and 8 is our y value. We're going to sub these into this equation that we have here. So 8 equals -3 plus 5 bracket squared plus b. Don't know what b is. That's the whole point of this question. We're going to try and work it out. What we've got is 8 is equal to -3 add 5 is 2. 2 squared plus b. What that really says is 8 is equal to 4 plus b. Well, if 4 plus b equals 8, well, b must be 4. 4 and 4 is 8. Okay, the value of b is 4. Sketch the graph of showing the coordinates of the turning point and where the graph cuts the x-axis. Okay, right, we covered this in, again, I'm not sure whether it was lesson 3, 4, round about there, possibly. Okay, right, what we can find from this is we can actually find the roots. Okay, what we're doing is we are setting the y value equal to 0. We're finding the points where this quadratic or the parabola crosses the x-axis, and we do that by setting the factors equal to 0. If that was equal to 0, move the +3 across, take it away, x is actually -3. Okay, and on this other factor, if that was equal to 0, x equals 0 plus 5, x is 5. Those are what we call our roots, our solutions. So let's have a wee look, find out where it cuts the axis. If I was to do a wee sketch, okay, as long as I have 5 on it. Let's see if we can make it a wee bit better than that. Let's have it. We'll say that's 5, and we'll say that's -3. Okay, remember it's just a sketch, it's not perfect. 5 and -3. That's where the graph cuts through. It's a minimum turning point. It's going to look something like that. Okay, we need to also find the turning point. Okay, the turning point, remember, is right in the middle. Right in the middle of the roots, -3 and 5. How do you find halfway between -3 and 5? The easiest way to find the halfway point of -3 and 5 is add the two numbers together and half it. -3 add on 5 is 2. Half the 2 is 1. Okay, that means the number 1 is bang in the middle of the two roots. Bang in the middle of -3 and 5. So I actually said find the coordinates of the turning point. We know the x value is 1. We don't know the y value, so way down here somewhere, you can't guess, okay, it's just a wee sketch. How do you find the y value? Well, you've got an equation to find the y value. The equation says this. We know what x is. X is 1, we've just worked it out. Sub it in. What we've got is 4, -4, remember these are brackets, these are multiplying, it's -16. So the turning point is 1, -16. So that down there is negative 16. It also said find out where it cuts the axes. We've only found out where it cuts the x-axis at negative 3 and 5. We haven't actually found out where it crosses the y-axis. Okay, how do you find where something crosses the y-axis? You sub in x is 0. Okay, it crosses the y-axis. You sub in x is 0. And that's what you always do to find out where something crosses the y-axis. Whether it's a trig graph, a straight line, a quadratic, a parabola, it could be anything, okay? Right, what we're doing, we're subbing in x is 0. Subbing it into what? Well, the y equals equation. What we've actually got here is 3. Remember these two brackets are multiplying. 3 times negative 5. So the y value is negative 15. So the actual coordinate is 0, negative 15. Okay, and that would be negative 15 there. Okay. Solving quadratic equations. You'll notice there's quite a bit in this, okay? You will get, I would say, easily 3-4 questions on quadratics in your exam question, possibly more than that. To solve quadratic equations, what we do is you'll notice the equations here are equal to 0, most of them. We'll get to the last one in a minute. The method we use is we factorise, okay? 3 to 4 different methods of factorising. You must be able to tell which is which. Always look for a common factor. There is a common factor. The common factor is 2x. Take out 2x as your common factor. If you take out 2x as a common factor, that's what you've got. Set your factors equal to 0. So x would equal 0. Remember, you can write 2x equals 0, but that just really means x is 0. And in your other factor, well, if x plus 3 is 0, x equals negative 3. Okay? 0, negative 3. 2 factors, 2 solutions. 2 solutions to your quadratics. Next one. There's not a common factor. Look for difference of 2 squares. Yes, it is difference of 2 squares. How you factorise is x minus 3, x plus 3. Square root of 9 is 3. Okay, and exact same method, set your factors equal to 0, x would equal 3 for this one, and x would equal to negative 3. Okay, we've already worked out how you, remember how you work out these factors before. Next one, I'm going to actually work out this up here. Okay, we're running out of space. Common factor, yes, you can see a common factor there. There's a common factor of 2. If I take out the 2 as a common factor, that's what I've got. Okay, it's not finished. The middle part here in the bracket is also a difference of 2 squares. Square root of 16 is 4. Okay, so this is really a mix of the first 2 types of factorising there. 2 factors, well, 3 factors, but these are the ones that could possibly be equal to 0. So on this side, x minus 4 equals 0, so x would equal 4. And on the other side, x plus 4 is 0, take the plus 4 across, x is equal to minus 4. 2 solutions. And third, this one doesn't quite look the same as the rest. What's the difference? It's not equal to 0. If you're solving a quadratic equation, it must be equal to 0. This must be rearranged first. How do we rearrange it? Well, bring the 8 across. Okay, onto that left-hand side. X squared plus 2x minus the 8, bring the 8 across, it becomes a subtraction. Trinomial, quadratic, factorising, 2 numbers that multiply to negative 8, they add up to 2. 2 numbers that multiply to negative 8 add up to positive 2 would be a plus 4 and a negative 2. Multiply to negative 8, add up to positive 2. 2 solutions, set the factors equal to 0, x is negative 4 and x is 2. Okay, and finally solve this and give your answer correct to 1 decimal place. This is a paper 2 question. I put it there as paper 2. If you attempted to factorise this, it's not going to work, okay? This is your quadratic formula question. I really should have put your quadratic formula on the screen for you. Remember, it is on your formula list, okay? This is your quadratic formula. It's on your formula list. Okay, A, B and C are your coefficients. A is 2. B is 5. C is negative 4. That's your numbers. We're going to sub them in, okay? X equals minus B is a minus 5 then. plus or minus square root. B squared is 5 squared. Don't work out any of these first. Sub them in. Okay, your first mark is for subbing them in. Take away 4ac, 4 times 2 times negative 4. And it's all divided by 2a. 2 times 2. That's how you get your first mark. It's a 3-mark question. That's how you get your first mark, by writing that out. Okay? Negative 5 plus or minus square root. 5 squared, 25. Take away 4 times 2 times negative 4. 4 times 2 is 8. Times by negative 4. 4 8s are 32. So it's negative 32. All over 4. Okay? Really what we've got here is negative 5 plus or minus the square root of 25 take away negative 32 is 25 plus 32. So what you've actually got there is 57, all divided by 4. For getting that 57 to this point, you have now got your second mark. You get your second mark for working out that 57 correctly. Okay? And this is where you get your two solutions. Solution 1, negative 5 plus the square root of 57 over 2. And your second solution, negative 5, take away the square root of 57 all over 2. Okay? And remember, I think I put there 1 decimal place. Right, let's get the calculator. Negative 5 plus the square root of 57. And you'll remember we've done this in lesson 4, 5, somewhere around about there. Press equals and divided by, why am I saying divide by 2? It's obviously divided by 4. Yep, divided by 4. On my calculator, I have 0.637, blah, blah, blah. It did say 1 decimal place. 0.64. Okay, and our second solution, negative 5, take away the square root of 57 equals, and divide it by 4. On my calculator, I have negative 3.137, blah, blah, blah. 1 decimal place, negative 3.1. Okay. I'm going to leave you some questions similar to these ones. Have a go and let me know how you got on. Okay. Good luck. Bye-bye.